guys, my name is Imam. So this I-SQL test, first test actually on Android. So we're going to open the project using C# Shell ID, the best ID for Android, for C# development on Android. You can use it for exam-minded forms and other many things. I can install NuGet in it, and it also like have full capabilities, just like Visual Studio, but not actual like Visual Studio, just a little bit concise, you know. So now we're going to open C# Shell. Okay, so actually I'm using a wireless keyboard in case you guys see it somehow complicated. Okay, C# Shell. Okay, so it is just another old project, so let's open the new one, the I-SQL project. Yeah, okay, press loading. Okay, I guess loaded. So we have many classes and namespaces. As you can see, it has folders in the project, and these folders are named based on the namespace. So there's the I-SAC namespace, which consists of the basic things of I-SAC, like what would I say, like the data type of I-SAC and other things like the parsing. So let's open it, let's see what's there. This is where the parsing classes, fundamentals, things of I-SAC, and some other interface. That's the I-parser and the I-types. That's I-SQL types. Then I-SAC.ISQL will have the create class, drop class, the connection class, exception class, show class, and suppressor. So actually we're going to see the use of that further. We have the collection class. The collection class is where I-SAC stores its data fetched from the dataset, from database. So we have a lot of them. We have the virtual table, virtual 3 map rows, table 1, table column definition, and the rest like that. We quite have a lot of interface too. Then the I-SAC.logic6, now we are going to testing today, the expression class and the logic expression class. So there's also interfaces, yeah. Then the query command, we have alter class to alter the table, insert query, and to relocate. So also that's all I think for now. So first of all, let's see about the exception. Let's see the expression class. So we have include using I-SAC.logistics. Right here. We have included that. So now we have access to our expression class. So expression class is very easy. It works in strings. You just actually, if you want to solve your maths, maybe like console.readline, you're collecting it as an input, but it's in a string format and you have to solve it. So instead of you using multiple read lines method to collect different inputs in different sequences, it's more better for you to just use this expression engine class just to solve this kind of simple mathematical problems. So the first step is we're going to instantiate the expression class. So expression, let's say exp is equal to new expression. So although it has two overloads, so there is there is the default constructor. The constructor have two overloads. So there is the default constructor, which is this, and it's also a constructor that allows you to put your expression directly into. So let's start with the basics. We'll have like 2 plus 2 So this is the argument we are passing into it. I also have then for us to tell the experiment engine that it should start solving, so we'll call the exp.calculate method. This method takes no parameters. So for us to see the output, so this actually what this calculate method does is going to start calculating it. So once we pass an expression or an argument or the math expression to the experiment engine, the first thing the experiment engine does is solve it. It's pass through it and see other things based on the way mathematical numbers need to be parsed. Then the calculate method just calculate it without redoing those things. Just go directly to the calculation. So for us to see the output, we have a method called the exp.results. This result actually have parameters, but you can leave it because all the parameters are all assigned. So if you want to change it from the normal one, you can say the cast type. It has the cast. So the cast actually have many. If you want to cast it to int, float, double, and decimal, so you can see them. Yeah, you can see it cast type decimal. I also have the round type. The round type, you have none, that's for nothing. If you want to round it floor, round, or ceiling to round it upper. So actually the default one is cast to double and the round type is none. So you can actually leave it just for this. So we can store this value we get for in a variable. Let's say for answer is equal to this. Yeah. Then we can say console to print our results. Console.writeLine answer. Yeah. Now let's run this. Okay, it's compiling. Okay, here we go. As you can see, it shows the way it solves it, the method it uses, so that's how it solves it. I'm going to explain it further. So let's put some thing here. Let's say answer is, then I'm sorry, let's run it again so I can explain it better. Okay, I can see this pre-add, color, pre-sub, power, mode, div, multi-add, sub. It's actually the method, the subroutines the expression engine used to solve mathematical expression. So what this pre-add and pre-sub do, it works when there's some other plus or minus joined with others like that, with other symbols like that. So the pre-sub and pre-add solve those symbols, not with the number, solve the symbols. So for example, we have like minus 5 plus 6. So that minus 5 is two separate arguments. There's a minus and there's a 5. So what the I-SQL expression engine does is going to call the pre-sub, since there's a minus there that have no other previous operand. It's going to simplify the minus and the 5, which is going to give us minus 5. So though they have nothing to do right here, so it's only 2 plus 2. So the power, mode, div, multi, add, they have nothing to do here except the sub. So if you can see, when the sub method is called, when the add method is called, you can see that's when the 2 plus 2 was last shown, but when it gives to the sub, it's already 4. So that's how it works. So let's see these of this pre-add and the rest. Let's say we have minus. I'll say once you run it, you're going to see is minus 2 plus 4, minus 2 plus 2. So it's going to give us, you see, minus, there's a space between the minus and 2. So when after the pre-sub was called, it was now become minus 2. That is solving. So now you can see it's 0. So there's some other rules on the expression engine, which is it doesn't accept you to write multiple plus or minus together joined like this, plus plus minus minus. The highest you can write is 3. If it's more than 3, it's going to yell at you. So let's see what I'm going to say. Okay, you see it says cannot join multiple arithmetic symbols together. Highest is 3, e.g. like plus plus minus. So we can put multiple ones if we want. We can say plus minus 3 divide by that 23. We run this. Yeah, so you can see it solves it. So by default it's cast to double, so that's how it gives you back. You see plus minus 3. You solve the plus minus 3 first, which is minus. Plus and minus first, which is minus. Then minus and minus, which is plus. Then plus 3 divided by 3. It's going to be 3 divided by 3, which is 0.1 blah blah points. The rest, yeah. Then the add method is going to add the plus and the number, which is going to give us the exactly number we need. So that's how it works. So you can also include brackets. So if you want to use the raised to power, for example, you want to say like 5 raised to power 5, you can use the exponential symbol, 5 raised to power 5. And if you run this, it's going to give us 25, hopefully. Oh, sorry, not 25. My bad. Sorry. 5 raised to power 5 is 3 to 1 to 5. Yeah. But 5 times 5 is 25, right? Yeah. Okay, here we go. Yeah, bullseye. So we can also work with brackets if you want to change the order of the way the expression engine solves, just like the way math solves. That's how it is. So we can say 2. So if we're using bracket, there's a rule that in calculations and other calculators you can just say 2 open brackets 5 minus 6. By default, the engine has already know which symbol is there, which is multiplication, but in the expression engine here you have to specify it. If it's times, you have to specify it. If it's plus, you have to specify it. If it's anything, you have to specify it. So let's say it's times. So you can also use multiple square bracket, like nested square bracket. There's no problem. Anyhow you want to do it, there's no problem. You just make sure your code is right. So you can also open another bracket right here and say divide and modulus. Yeah, let's say 12 plus 3. And there's a secret here. If you want to use raised to power with some expression, you can use raised to power, then open bracket. Yeah, open bracket like 3. 2 modulus 5. Let's give some space so it's can be clear. Okay, 2 modulus 5 divided by 3. So actually this what's it called, this exponential symbol here, it holds this expression in this bracket, which is 2 modulus 5 divided by 3. So it holds it, so it's going to solve it first because that's the innermost bracket. It's going to solve it first before it goes outside and the rest. Let's see how it works. So so as you can see, the brackets is this is what it holds first. This is the expression 2 times open bracket 2 minus blah blah blah. So the innermost bracket is 2 times 2 modulus 5 divided by 3, which is what it first picks. It picks that and solve it. When it's done with solving it, it picks the next outside bracket. That's 12 plus 5 raised to power, the answer right here, which is this 12 plus 5 raised to power, the answer. So you don't solve that again, How I solve that is going to go outside. That will be 2 minus the answer right here modulus 5. I can see it. That what it does right here. 2 minus the answer right here modulus 5. It's also solved that. How is done with solving that, then it now goes to times 2. Times 2 with the answer is going to give you the answer. Do you see? The answer is blah blah. So there's a thing that I-SQL expression engine supports, which is actually amazing. I love it when I implement that in the engine, which is accept you to put variable names, to like assign variables, to put variables like say a plus b, then later you now give the value of a or b like that. That's how you solve it. It allows you to do that. So in a simple quick recap, so there's a syntax of assigned variables. There's an I-SQL column variables sign, and there's normal variable sign. So first of all, a variable name must start with a letter or underscore, then a number or another thing, just the way normal program languages variables instruction follows. That's how it also follows. So it's just like this at the variable, let's say the variable name based on I-SQL database columns, you can say maybe at table1 dot id plus the rest of the thing. It accepts that, and you can also use the normal variable declaration, so which is a minus 32 plus 5 divided by 16, for example. So now if you say you want to run this, it's going to give you an error because these variables, they are already assigned, so it's going to give you a runtime binding error. It's loading. Okay, you see operator mismatch because it doesn't understand what end up at the end, like you don't understand. So let's say, sorry, instead of 16, let's say b. So now for us to assign these variables, we can say excuse me. So for us to assign these variables, we can use the we can use what's it called, the exp dot set value. The set value throws an exception. Okay, this is what actually the set value does. It's how will I say it? Okay, it's it sets the value of a variable if the variable doesn't have a value. But once the variable has a value and once the set a value, it's going to throw an exception. For example, let's say the variable name first here. Let's say you want to set the variable name a. Then the value is 15. Then exp dot set value, which is b, and the value is 16. So now if we run this, it's going to run perfectly fine. It's going to run perfectly fine. You can see, so it actually gives a 15 and the end part, which is b, that's 5 divided by b, which is 6. We assign to 16, it changes to 16. So now if we try to use the set value method again to say exp expression dot set value, we want to set the value of a again. It's going to say a already have a value. Let's say we want to change to 20, which is going to say a already have a value. The variable name a already have a value. So you see, the variable a already have a value. So always note of which variable names you are changing. So for us to change variable names, even though it has a value or not, we can use, instead of us using the instead of us using the what's it called, the set value, we can use the change value method. This change value change any.
It's 2:24 p.m. You don't have any new notifications right now.
So let's say we have to change the variable name A again, and the what's it called, the value should be 20 this time. It's going to work perfectly. It's going to change it from 15 to 20. That's how it works. Let's observe. It's running. Okay, you can see it changes to 20 this time. A is the first variable argument in the expression, so it actually changes. You can change variable multiple times, and you can do other things. So the thing again you need to know about I-SQL expression engine. Actually, when it's solved, that doesn't mean this expression you put is gone. You can actually, after you have solved it, you can actually use this answer. For example, the answer you got from that, and now recap it. Let's say console dot write line this time. Okay, first arguments done. Okay, then now we can use it again to say, to do that we can use the add no, not to add. If the add method is used to add the add argument is used to add more arguments to a previous argument if you want. But now what we're going to do is this simple. We can now use the value we get from the previous answer and set it for another variable. Let's say exp dot change value. Let's say the variable name is b, then the value should be the answer we got. Then now exp answer is equal to exp dot results. Okay, let's run this time. It's running. Oh, sorry. You have to calculate again. exp dot calculate. Now it's going to work perfectly fine. Yes, you can see. So this is the answer at the end of the first argument. You can see the answer is 20 minus 32. If it's subtracted, that's going to give the answer. So actually when we substitute it, it now give the answer is minus 12.3125. So when we substitute that with b, it's going to add again to that previous exception that we have, argument expression that we have. It's going to use that same expression again and do more. So for us to add more, what's it called, to add arguments to the previous argument, actually say exp add arguments. To add arguments, I'll say from the previous one we have to put a symbol that is going to join it with the previous one. So it's going to be like, let's say multiply 6 minus previous argument. So if we run this now, it's going to work. If it is supported,
It's 2:29 p.m. You don't have any new notifications right now.
Okay, another new one. Okay, I think there's an issue. That's why I say it's a test. I think there's something that I'm going to fix there. Okay, I figured out that I know what I'm gonna do. Okay, so that's about the expression engine class. That's about the expression engine class. We also have the logic expression engine. So in the next video, I'm going to show you about the logic expression engine. Please hope to give feedback and other things based on this project I'm working on. This I-SQL project, but this is just a part of the project. We're going to see more details about the I-SQL itself. So thank you for watching, and please, I would like to see your notification on any guidelines and anything that you think I can do to make it more better. So thank you, and God bless you.